y'all. Today we're going to be going over this multi-stage inspection analysis type of problem. Now we're most likely going to get this in the exam, and so I wanted to go over just some sort of type of problem we might see. And I've added some, parts that could definitely come up, and I will go over them. For this first problem, or for this first video, what I'm going to go over specifically is the voltage gain. Now in the second and third video, I'll teach y'all how to do R in and R out. If y'all don't already know how to, or you can get definitely some practice here and kind of see my thought process of doing these, but we're going to stick to voltage gain. Now for voltage gain, or for any inspection analysis, we are in AC. So if you notice, now don't get confused here, we have a DC component and we have an AC component. Vn, lowercase vn, will be an AC component. 2 volts here is a DC offset. So we have 2 volts. Essentially what we can see here is we can have our regular sine graph here, right? And that'll be our Vn. But with a DC offset, we're going to be now at 2 volts at 0 time. And now it'll look like this. Something where we have a DC offset of 2 volts. So that's just to give you an idea. But now that we're in AC, we don't want that 2 volts. We only want Vn. So what do? We short all of our DC sources. So now this becomes a short circuit. Okay, so all I'm going to do is I'm just going to erase this and replace it with a short. Okay, same thing. You have to be very careful. Same thing with your VCC. This becomes ground. So now all of these go to ground. What else do we know? Well, as omega approaches infinity for AC, what do we notice? Capacitors, 1 over j omega, this becomes what? 0, so they short. So what happens here is C1, if we notice here, becomes a short. That actually shorts out R1. So what can we replace RE1 with? We can replace it with a wire. Go straight to ground. Same thing with this C2 over here. We have some sort of high-pass filter. Right here, we have a high-pass filter. And at high frequencies, it passes through. So we replace C2 with a short. So now instead of C2, it will just be a short circuit, a wire. What do we know? RC3 is in parallel with RL. Okay, so now we've replaced all of our DC sources. We killed all our DC sources and replaced them with short circuits. And if there were current sources, it would be open circuits. Capacitors become shorts as well. Okay, so now we're in the AC domain. What do we do now? Well, we're looking for gain. So usually in the problems, they might ask for labeling your stages. Now this may not be very easy to identify. What I would recommend you do is, I can't do it on here because the background is black, but you are going to outline, follow the cheese, as Dr. Xu says. You will follow the path of the signal from V in to V out. So let's do that. With this green marker here, I'm actually going to do it a little bit thicker here. With this green marker, I'm going to follow the shortest path to the V out. So from here, where do we go? We should go to VC. We should go to the collector of Q1. Go here. Okay, well, I mean, the easiest way is to go down because we want to get to V out here. So let's go down, right, through the emitter. Then, well, we don't want to go through the base, so let's go here. So we stay emitter collector, and then we go there. So what do we know? I'm going to actually, I'm going to have to back out so we can see this, but anyways, Q1 is a what? What kind of amplifier is it? Well, it's a common emitter. Remember, we're going to label this, or this is called the emitter, right? So whichever path our green line does not touch will be what we call our common, or our amplifier. So since it doesn't touch the emitter, it's called the common emitter amplifier. Q2. What does Q2 not touch? Well, it doesn't touch the collector. So we have a common collector amplifier. Q3. it doesn't touch the base, so we have a common base amplifier. So we actually have each of one. That wasn't my what I wanted to do, but it ended up being that. Anyways, now we have to label our stages. So we have 3 amplifiers, so we should probably have at least 3 stages depending on um, the complexity of this. So what do we know? This entire node here is Vn, so we don't have to label that one. But we want to find the voltage at this point, VO1, which we'll label it, because we don't know what this drop is, right? It's not going to just be a regular 0.7 or not even that. Um, just knowing in AC what that voltage with respect to the other one is. Um, so the next one would be VO1. This is all the same node, so you don't have to worry about it. Now this one is across a base and emitter, but in AC you have to be a little bit careful. So let's say this is VO2. Then we're going across a resistor, so we would have to find some current, but remember we're not doing anything in DC, we're in AC, everything's by inspection, so we will label this as VO3. Now afterwards, we want to follow this path here, follow the green, and then after we pass up Q3, we get to V out. So we don't have to label anymore. So what do we know? V out over V in is our voltage gain. This is equal to AV. Is going to be equal to what? V1 over V in times V2 over V1 times, VO1, VO2, VO3 over VO2 times V out over VO3. This will end up giving us V out over V in. And if you notice, there are 4 stages. I call each one of these stages because if you think about an amplifier, you have some sort of, this is kind of like your basic amplifier part, right? So this is connected to ground. This is plus minus V1. This will be AV1 and this will be V out, right? So you have, this is V in. You might have some resistor here, like a voltage divider. And this will be some sort of dependent source. So V out over V in, this is entirely one stage. That's how you get, your black box amplifier. Anyways, now let's try and look at our inspection sheet to figure out what do we need to know to do this. It's actually very good, a good practice if you label your amplifiers, because at this point, once you look at your inspection sheet, it's very easy to just take that equation and solve for it. So let's start from the left, move to the right. So starting with VO1 over Vn. We know it's a CE amplifier, so we should look at the CE amplifier on our inspection sheet. One thing I forgot to mention is that VA is equal to infinity. We'll leave that as is because if not, it would complicate this question very, very much. If you can't take VAs, or if the teacher gives you VA is not infinity, you would have to use a longer equation with RO as well as some other variables. Anyways, VA is infinity, so we don't have to worry about output resistance or RO. Now VO1 over Vn, we're looking at CE amplifier gain, is going to be negative GM1. Remember, you have to label which GM it is. We have 3 different transistors, so that's 3 different GMs. GM1 times RC, so the collector resistance, divided by 1 plus GM1 again, RE. Okay, so RC, what is that going to be? Well, let's see, what does the collector of Q1 see? If we draw an arrow here, we call this RC. Well, it sees RC1, but it also sees, what else does it see here? Well, it sees, oh my gosh, oops. It sees everything looking into the base of Q2, or B2. So we actually have to put those in parallel. So what we're going to end up getting at the resulting equation would look something like this. Equals negative GM RC1, right? Because we see RC1 from the collector of the first transistor in parallel with RB2. This is because they share this. Oh my! there's too many things here, sorry. They share the same node, and they end up getting connected to the ground. So they're in parallel, essentially. Now, it's all divided by 1 plus GM1 times RE. Well, the emitter of Q1 is 0. So we can actually get rid of it and just call this 1 plus 0 is 1, so let's get rid of the denominator. That's all this is. Now we have an unknown, it being RB2. What is RB2? RB2 is the resistance as seen by the base, or looking into the base of Q2. Sorry, the wording is a little bit kind of funny. You have to be very, very clear with how you say it. So you're looking into the base of Q2. That's what RB2 is. Now, it's a diode connected transistor. This is something I recommend you put on your crib sheet. If you have a diode connected transistor, what this will end up giving you in resistance form is it's going to be 1 over GM in parallel with R pi. Now what you can say is that I believe it's GM R pi is much greater than 1, which is, this is beta. Beta is equal to GM over GM times R pi. Let me make sure, sorry, oh my gosh. Make sure this is exactly what it says. Yes, is much greater than 1. So, I believe this is what it is. So 1 over GM in parallel with R pi is essentially 1 over GM. So you can model a diode connected transistor as a resistance of 1 over GM. Very, very important. This is, I would put this on the crib sheet just to make sure, because you don't have the time to do small signal analysis for each of these diode connected transistors. So what I'm going to do now is, now that we know this, RB2, looking into the base of the second transistor, we see this. We see ground. We see another transistor, RC2, which is, if we scroll up here, this resistance. And it's connected to what? VO1. So this is VO1. And this 1 over GM1 will be connected from VO1 to VO2. So it's actually going to look like this. VO1, VO2, and this is 1 over GM2. And then what's going to come after is it's going to look like the next thing, which is RE2. The next resistance, RE2, which then has VO3. You're seeing there are a lot of resistances and voltages in between. And then what you have here is actually looking into the collector, emitter of 3. So this is we're going to label this as RE3, looking into the emitter, which we can then label here. And this will be connected RE3, which is VO3, and then that is connected to RC3 in parallel with RL, because now we're looking here into the collector. Now, we're really only seeing RE3, so we're fine here. All right, I don't have to get too far because we're going to go later in. We're going to do more labeling of this in just a second. But this is going to be essentially what we have. Yeah, because right then what we would have is V out, and then we would have some other stuff. I'm not going to get into that right now, but this is really what I wanted to get into here. This stuff. Because there are many ways about doing this. And this is one of the ways that Dr. Xu does it. She provides voltage dividers. This is what this is going to be. So, what is VO1 over VN? Well, looking here, we need RB2, right? So what would RB2 be? Well, now that we're seeing this, RB2 is where in this circuit? That's what we need to figure out. Okay, so RB2, let's see here. Okay, so yes, this is what this bottom here, I made sure to recheck my work because sometimes this can be confusing about what these resistances should be. Now, just so we're clear here, VO1 is going to be connected to what? RC2, RC1, and the Q1 transistor. And we can verify this by looking at this picture here. VO1, which is here, is connected to RC1, RB2, and Q1. Of course, RB2 is what the is 1 over GM2, right? In series with RE2 and RE3, which we labeled as RE3 is looking into the the emitter of Q3, and it's in series with RE2. So RB2 is going to be, let's see here, is all of this. Let me label it so you can see it a little bit better. Is going to be all of this, RB2. This is going to be RC2 in parallel with 1 over GM2 in series with RE2 in series with RE3. Now, a problem here is what is RE3? Because RE2 is explicitly a resistor. RE3 is components from, again, a common base amplifier. So we need to verify what RE3 is. RE3 looks into the emitter of a PNP transistor with a base resistance of RB3 and a collector resistance of RC3 and RL. Be very careful. When you are doing gain, you keep RL. You do not take it out. You keep RL in your equations. So now, looking at your crib sheet or looking at the inspection rules, find the resistance as seen, or looking into the emitter of a transistor. What do we know? Well, looking into the emitter with VA infinity, it becomes 1 over GM plus RB, which is RB3, over 1 plus beta. And I would put this, state your assumptions, assuming beta is equal to GM R pi is greater than 1. If you're uncomfortable with making this assumption, use the other equation, and I'll write this down, but I'm going to use the assumption. This is the other equation, R pi 3 plus RB3, that other longer equation on top, or I guess right above it actually, in parallel with R pi 3 plus RB3 over beta, which is also equal to R pi 3 plus RB3 over 1 plus beta. Okay, so you can use either of these equations. I'm going to use this top one because it's a little bit smaller, but both of these will work as long as you state this assumption. Be very careful about what you assume. So now, are there any other equations or variables in here that we have to verify? Not exactly. I think we're pretty much done here. Be very careful. I forgot GM3. Make sure I don't miss anything else. Yeah, everything else looks good. So now we've found what? We found RE3, which can then be plugged into this equation to find RB2, which can then be plugged back in into here to find VO1 over Vn. So now we found VO1 over Vn. That was quite a doozy. Next thing is VO2 over VO1. But now that we've found our resistances, it makes it a little easier to solve. VO2 over V1. What is that? VO2 over V1, well, looking back here, we have what? A voltage divider. So what is VO2 over V1? VO1? Well, VO2 over VO1 is going to be this resistance, or really, it's going to be the voltage across these two resistors. So we can actually redraw this. It might be a little easier for you to see like this. This is VO1. This is 1 over GM2. Sorry, let me rewrite that. 1 over GM2. And then what do we have here? VO2. And then we have these two resistors, RE2 and RE3. Now, this should make a little more sense. VO2 over VO1 is going to be equal to RE2 plus RE3 divided by RE2 plus RE3 plus 1 over GM2. And remember, we've already initialized RE3 up in the top, so we don't have to initialize it anymore. The next thing is VO3 over VO2. And we're going to do essentially the same thing. VO3 over VO2. Now we're going to draw this next one. It's going to look like this. VO3 is just the voltage across RE3. So this is going to be VO3, RE3. And what is it going to be? It's going to be VO2, which will be over here. And then in series with RE2. So what is that? Well, that's the voltage divider again. RE3 divided by RE3 plus RE2. And now for the final part, we need V out divided by VO3. Well, V out over VO3, what do we notice? What kind of amplifier is it? We have a common base amplifier. So looking at the inspection sheet, common base amplifier with VA is infinity tells us V out over V3 is equal to GM, remember 3, RC, the collector resistance, which is going to be RC3 in parallel with RL, because remember, we're looking out. Think about what does the transistor see? This is RC. Looking out of the transistor to the collector, we see RC in parallel with RL. So that's how I get RC in parallel with RL. Now, it's all divided by, oh, never mind, sorry. It's multiplied by R pi 3 divided by R pi 3 plus RB, the base resistance of the third transistor, which is RB3. And that is how you get the gain. And now we're done. So we did this all in stages. At this point, you do not have to rewrite anything. Do not put anything in back into all of the equations and try and simplify. Leave it as is. As you can see, this is a very long process. And this takes a lot of knowledge about where does the voltage lie. This is very important. Knowing your small signal analysis and your equivalent resistances. Very important. Knowing what kind of amplifier type it is. Very important. You will only get good at this if you practice. This does not come overnight. I promise you, it does not come overnight. So you guys have to practice this. If you guys have any questions or if you think I did something wrong in this case, please let me know, because obviously I'm still learning too. But if you guys have any questions about what I did and why I did it or how I ended up getting this, please let me know. Otherwise, if you guys have any problems, if you guys are okay, that's perfect. Then that would be our equation for VO1 over Vn. Of course, at the end, we'll multiply everything. Make sure you have all of your equations in terms of something that is known. Anyways, thank you for watching the video. In the next couple of videos, we're going to actually be doing R in and R out of this exact same circuit. So if you want to get ahead and try and do that, I'll probably post this post this tonight, but I'll post R in and R out, or I'll do R in and R out tomorrow. So, anyways, thanks for watching, guys. I I legit just made up this circuit, just trying to make something that is doable with these sorts of amplifier types that we have. Anyways, I'll see y'all tomorrow. Thank y'all for joining.